Welcome to EDU World Space.
Which of the following statements about effective nuclear charge for the outermost valence electron of an atom is incorrect? Let's first look at the effective nuclear charge. So the effective nuclear charge which is Z effective, EFF, is the charge experienced by the outermost shell by the nucleus. It is the inward pulling attractive force that keeps the nucleus and electrons bounded. Each electron present experiences an effective nuclear charge due to the screening less than the actual nuclear charge due to the screening or shielding effect by the other electrons. The formula for calculating the effective nuclear charge is equal to Z minus S. Here, Z is the atomic number, and S is the number of shielding electrons. For a valence electron, most of the shielding is due to core electrons which are very close to the nucleus. Therefore, the value of S which is a screening constant for a valence electron is nearly equal to the number of core electrons. Electrons in the same valence shell do not screen one another effectively, and therefore affect the value of S slightly. Now let's look at our 5 statements and determine which one is incorrect. So for statement number 1, we know that the formula for the effective nuclear charge is equal to Z minus S. It is clear that the effective nuclear charge is a true nuclear charge minus the screening constant due to the other electrons in the atom. Therefore, this statement is correct. Statement 2. When moving from left to right in the periodic table, it is observed that the number of shielding electrons remains constant, while the number of protons increases. Therefore, this statement is true. Statement 3. Valence electrons screen the nuclear charge more effectively than do the core electrons. This statement is false. As the effective nuclear charge would be screened more effectively by the core electron. So that is our false statement. For 4, the effective nuclear charge shows a sudden decrease when we go from one end of one row to the beginning of the next row of the periodic table. And so this statement is true. As the end of the row contains noble gases, which have fully filled orbitals, while the beginning of the row, if we look at rubidium, has a single electron, and that would provide shielding. So the beginning of the row, look at the element rubidium, for example, has one valence electron, and the single electron provides shielding effect, thus causing a decrease in the effective nuclear charge. And our last statement, statement 5. The change in effective nuclear charge going down a column is generally less than that of going across. So as we move down a row, as we move down a column, it is observed that there is an increase in the number of orbitals that leads to an increase in the size of the particular element Well, there is no increment. In the number of orbitals. It is true to say that the change in effective nuclear charge going down a column is generally less than going across a row. Therefore, out of the 5 statements about effective nuclear charge, the statement that is incorrect would be statement number 3. Statement numbers 1, 2, 4, and 5 are all correct.